We are doing comparing relationships with tables. We're back to tables again, lesson 7. Our learning goal is let's explore how proportional relationships are different from other relationships. So we've been talking about is it proportional or not, and we're going to continue talking that. And by the end of today's class, I can decide if a relationship represented by a table could be proportional and when it is definitely not proportional. So we're going to get into a little bit of semantics about definitely proportional and just could be proportional. So we're going to start out by looking at some prices of smoothies at 2 different stores. So at Smoothie Shop A, an 8-ounce smoothie costs $6. What is this column right here telling us? That is your constant of proportionality. That is your y over x. Okay? So from looking at this store, does it look like there is a proportional relationship?
Is this the last page of the notes?
Yes.
Yes.
This is the summary. Okay? Does it look like it's a proportional relationship? Yes. Okay? But can we say definitely for sure it is? For every smoothie that we buy, if I buy a 32-ounce smoothie, is it going to be 75 cents per ounce? Do we know that? No. We only know that in these cases it is proportional. Now, if they gave us the equation for this, if all they told us was this, that at Smoothie Shop A, the price equals 75 cents times the size or the number of ounces, is that a definite proportional relationship? Yes. That one is definite. This one is only true that we know for 8 ounces, 12 ounces, and 16 ounces. It's just a little nuance there so that you understand that, yes, this table is proportional. But does that hold true for every smoothie at the store? We don't know. Okay, we just don't know. All right, now at Smoothie Shop B, this is our COP or our y over x table, or our y over x. Is there a proportional relationship at Smoothie Shop B? No. We can say that it is definitely not a proportional relationship because depending on the size, you pay a different amount per ounce. Questions you have for me on that? All right, let's move on to the practice problems then. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would the COP be? So the first one is about a loud sound and how loud a sound is depending on how far away you are. Okay, so we need to determine if it's proportional. How do we determine if there is a proportional relationship and we're looking at a table?
With the other number.
Okay, so you've got x and you've got y, and we keep saying y over x. That means y divided by x, just like you said. So I'm going to take 85 and divide it by 5. What do I get? 17. Thank you. Somebody brought their calculator. Okay, now I'm going to do 79 divided by 10. Oh, that one you don't need a calculator for. That is, when you divide by 10, you just move the decimal, right?
7.9.
Okay, is there a proportional relationship between the distance a listener is and the sound level of a noise?
No.
No. Do I even need to go on?
No.
Nope. This is not proportional. And you can probably ask Ms. Kilbane why it's not proportional. Okay, it's a good science question. All right, cost of fountain drinks at the hot dog hut. Okay, we're gonna do the same thing. We're gonna figure out the cost per ounce. So we're gonna do y over x. We're finding that unit rate, aren't we? And the unit rate is the COP. Okay, so we're gonna take $1.49 divided by 16. So how much is it per ounce at the hot dog hut?
We got a big decimal. It's so I say
0.09. What else is after it?
31215.
Okay, we'll just stop there. Money gets rounded to the hundredths place. So this 9 is in the hundredths place. We look at the next number. Does the 3 make that get bigger, or does it keep it a 9?
Keep it at 9.
Keep it a 9. So this is going to be 9 cents per ounce. Okay? All right. Let's see if it's still the same, if it costs the same when we buy a 20-ounce drink. So we're going to take $1.59 and we're going to divide it by 20 ounces to figure out how much it costs for 1 ounce of drink. Chloe, what'd you get?
0.07985.
795. Okay. Hundredths place is right here. Does that 9 make that go to 8, or does it stay a 7?
It makes it go to 8.
Good. Okay. So now it's only costing us 8 cents per ounce. Is this a proportional relationship?
No.
So this one is not proportional. Now, my expectation is that either you are 1, writing this down on paper, or 2, you have the PDF up and you're annotating on your iPad. My expectation is not that you have the quiz pulled up and you're just entering the answers, because that's not going to help you a whole lot when you go back to study, because you're not going to have the problems worked out to look at. All right? Do we understand the expectation for what we're doing?
Yes, and I
Okay.
try.
Okay, if you would like to take a screenshot of that, I am fine with that. I'll step out of the way. Okay. Are these the same? My multiplier is not the same, so therefore it doesn't have a proportional relationship. They all have to be the same to be proportional. They have to be multiplied by the same thing.
Is the COP the same thing as proportion?
The COP is what we use to determine if it is proportional. If it has a COP, if all of these numbers were the same, like in the smoothie problem, store A, they were all 75 cents. That makes that relationship proportional because there is a COP, because the unit rate is the same for every drink. Here, the unit rate is not the same for every distance, okay? Here, the cost is not the same for every size drink.
So I think what she's asking, if I'm correct, Addie, if this number here, the 17 and the 7.5,
Yeah.
those two numbers, if they were the same numbers, then that could be the COP.
Because see, here I'm multiplying this by 17 to get 85. Here, if it was proportional, I would be multiplying it by 17, and I should have 170 here. But I don't. I have 79. This multiplier was 7.9. So it didn't get multiplied by a constant.
Yeah, all the same thing.
They all have to be multiplied by the same thing to be proportional.
And
You're welcome. That was a great question. Okay, anybody need more time? All right, find my little thing here. All right, let's go on to question 2. A taxi service charges $1 for the first tenth of a mile and then 10 cents for every additional 1/10 of a mile after that. Well, that sounds pretty confusing. So I'm going to do a little bit of a picture here, and maybe that'll help you understand it. So what it's saying is, if I get in the taxi at 0 miles, I haven't gone anywhere, I get in, the first 1/10 of a mile is going to cost me $1. So as soon as I sit in that taxi and go 1/10 of a mile, he's going to charge me $1. Then every 1/10 of a mile after that, I get charged 10 cents. So if I go 9/10 of a mile, so that's 1/10, 2/10, 3/10, 4/10, 5/10, 6, 7, 8, 9/10. I've gone 9/10 of a mile. I'm going to pay $1 for this 1/10, and then for the remainder 8/10, don't I have 8/10 of a mile further to go? I am going to pay 10 cents per tenth. So I'm going to multiply that 10 cents times 8 because I have 8 more tenths to go. So the cost of that ride to go 9/10 of a mile is $1 plus 80 cents. Does everybody see where I got both of those from?
Yeah. So 1 mile is 80 cents.
No, not 8/10 of a mile is 80 cents. 8/10 of a mile is 80 cents after you pay your $1. So this ride is going to cost me $1. Yeah, $1.80. All right, let's look at the next one. Do you want to take a screenshot of that so you got the picture? Who needs more time? Because I'm going to erase the picture. Okay. Now we are going 2 miles. How many tenths are there in 2 miles?
20.
20, okay? So we have 20 tenths. Well, the first tenth costs me $1. The first 1/10 of a mile costs me $1. How many tenths do I have left?
You have 19 cents.
I have 19 tenths left, and they charge me 10 cents for every one of those tenths. So this is going to cost $1.90. So what is my total cost to drive 2 miles?
$2.90.
Awesome. Okay. If you want to take a picture of that, how we got that, you can, because I'm going to erase it. So there are 20.
So is there a COP for this?
I don't know. We're going to find out. Okay? We'll get there. We got to fill in the table first before we can figure it out. All right? Can I erase?
Yeah.
All right. Now we're going 3 1/10 miles. 3 1/10. Well, 3 miles would have 30 tenths, and then I'm adding 1 more tenth. So I have 31 tenths of a mile. The first one costs me $1. How many do I have left now?
30.
30. It cost me 10 cents per tenth. So I'm going to multiply that. So that's going to be $3. So what is my total cost to go 3 1/10 miles? $4. Okay. who needs more time? All right, now we're going 10 miles. How many tenths are there in 10 miles? 100 tenths. So the first one cost me $1. How many do I have left? 99. So I'm going to take that 99, multiply it by 10 cents. So it's going to cost me $9.90. So what's my total cost to go 10 miles?
$10.90.
Okay, now somebody said, is this proportional? How do we determine if two values, two quantities are in proportion to each other? Chloe?
The y column, the answers all have to be the same for it to be proportional.
When we divide it by the x column, okay?
Yes.
So when we do y divided by x, do we get the same constant that this got multiplied by? Are they all getting multiplied by the same number? If they are, then it's a proportional relationship. If they aren't, then it's not a proportional relationship. All right, so we're going to take out our calculators because this looks pretty nasty. 1.8 divided by 9/10, which you could write this way and then it doesn't look quite so bad. What do you get?
2.
Okay, so that is saying that the cost per mile is going to be $2 at this rate. Okay, now we're going to take $2.90 divided by 2 to find out how much 1 mile costs here. What do you get?
1.45.
$1.45. So this is saying if I go 2 miles, my rate is $1.45. Do they have the same rate? No. So is this proportional? No. Okay? And the reason is because you start out having to add $1 right up front. Okay? If you go back to the activities with the going to the state park where you had to pay $6 for the car to get in and then that was $2 per person, that adding that $6 every time makes it not proportional. Okay?
Can you move? I can't.
I'm so sorry.
Thank you.
You're welcome. Okay, take a screenshot of that if you didn't get it written down. Do we even need to go on? No, we know right now it's not proportional, so we don't have to go any further. All right, who needs more time? Awesome. All right, let's move on to question 3 now. Question 3, we've got a rabbit and a turtle. Oh, that classic race. Is the relationship between the distance traveled and time proportional for either one? If so, write the equation that represents the situation or that relationship. Okay, how do we determine if it's proportional? Divide y over x, right?
X and y over x.
Okay, so we're going to do y over x. So take out your calculators and do 2 divided by 108. You get a super long number, don't you?
Yes.
0.018518519. That's all it gave me.
Okay, that's okay. All right, now that's doing 2 divided by 108. Okay, now do 7.5 divided by 405.
Divided by what?
405, the x.
I got the same thing.
Did you get the same thing? Okay.
185.
How about 10 divided by 540? Do you get the same thing?
Same thing.
Okay. And this is a nasty number, isn't it? Same thing here. You have to test them all. Do you get the same thing here?
Yes.
Okay. Now, I've always told you to do y over x, right? This equation would be, if this is t for time, d for distance, and the equation is always in the form of y equals kx, this equation would be t equals 0.018518519D. Now, we learned the other day that we could write the equation going the other way, right? So what is our multiplier? What do I multiply 2 by to get 108? So take 108 divided by 2, what do you get? Take 108 divided by 2, what do you get?
54.
54. Take 405 and divide it by 7.5, what do you get?
54.
All right, so if I use D first, D is going to equal 54T. That's saying X equals KY. In this case, X is D and T is Y. And remember, we learned we could do the reciprocal. By flipping the table, we have to take the reciprocal. And the reciprocal of that nasty decimal is 54.
Miss Blair,
Yeah.
so when I divide that and I get that decimal, there's no 9 in it.
Okay, your calculator doesn't go that far. That's fine.
So, which one would be the equation?
This is the one I want you to put in there because I wanted you to start with D.
Okay.
Okay? Do you see where the D one came from though? I actually did X over Y instead of Y over X. Because
So
that,
you put D in? The D
yes, you're putting the,
Okay.
no, I think I put D equals blank
Value.
and you're gonna put in 54T.
I'm going back and forth, Miss Blair, but there's like there's another one like on top of that. Like there's another type you're answering.
Yeah, it wants to know which animal has the proportional relationship. Which animal? Well, we just determined the turtle does, right? Now we're gonna look at the rabbit. Does the rabbit have a proportional relationship? Let's do y over x. Well, this ends up being 1 over 800. This ends up being 5 over 900, which reduces to, let's see, 5 will go into that, 5 will go into that with 4 over 180. Is it proportional? Nope. Okay, so the rabbit is not proportional,
The turtle.
but the turtle is, and that means he runs at a constant speed. He's running at 54 meters per minute.
Thank you.
Okay? Questions you have for me?
So you want us to put not propositional for the rabbit's run?
That would be a true statement. It is not proportional for the rabbit. I don't think you have to enter that answer on the quiz, but in your notes, you probably want to write that down.
Miss Blair.
Yes?
You said he's running at what?
He's running at 54 meters per minute.
Okay.
All right? All right. decimal was proportional?
Wait, the turtle.
So you're gonna put turtle in the blank, and then you're gonna tell me it's D equals 54T. But I think I gave you the D equals, so all you gotta put in is the 54T. All right, if you're,
The 54G.
yes, the 54T. Okay, if your birthday is in
What
January,
does D stand for?
distance, and T stands for time. The two headings on the table, okay? That's where I got that from. Good question. All right, we ready for 4 now? I don't want to rush you.
Yes.
Okay, if your birthday is in January, February, or March, or, yeah, January, February, March, you're going to do A. You are finding the constant of proportionality. If your birthday is in April, May, or June, you're going to do B. If your birthday is in July, August, or September, you're going to do C. If your birthday is in October, November, or December, you're going to do D. Okay, I'll give you about 2 minutes to do that. Go. Okay, turn off your... All right, who needs more time? All right, January, February, March, babies. What's the COP for A? What's that multiplier? What do I multiply this by to get to here? 7. Do I multiply that to get to 7?
Yes.
So if I did this all the way down, if I did 14 divided by 2, 35 divided by 7, our COP is 7. April, May, June, babies. What's our COP here?
120.
120. Very good, because this times 120 gives me that. Same thing here. And we find that by doing y over x. Okay. June, July, August. No.
125th.
125th. Okay. All right. It could also be 0.04.
Yes.
Okay, either one will work. Okay? And you got that by doing 3 divided by 75. All right, how about my fall and winter babies here? October, November, December.
EOP is 2.5.
2.5. You can write it in as 2 1/2 or even 5/2, because you get 10 over 4, which equals all of those. All right. Questions you have?
For number 3, does it matter which one we write it as?
No. Both. I think I have both of them in there as possible answers. Same thing with the fourth
Yes.
one. Okay? All right. We ready to move on? Who needs more time?
Me.
Okay.
So for this, do we have to write down all the COPs when we actually take the quiz on it?
Yeah, you have to write down all the COPs. It'll say table A COP equals, table B COP equals C and D. Okay? Take a screenshot if you need to. Alrighty. I think we're on the last problem now. Yep. Alright, Karen and Mai are standing at one corner of a rectangular field of grass looking at the diagonally opposite corner. Let's draw a picture. So they're standing at a field. It's a rectangle. And they're looking at that diagonal right there. That's supposed to be a straight line. Okay? Karen says that if the field were twice as long, so if I draw another field, and I multiply that by 2, and the width is twice as long, I multiply that by 2, she says the distance of the diagonal would also be multiplied by 2. My says, no, it would be multiplied by more than 2. So Karen says this is true. My says it would be multiplied by 2 more than 2, so plus 2. Multiplied by more than 2. So who do you think is true? Who do you think is right?
I think mine is right.
You think mine's right. It's going to be multiplied by more than 2? Okay. Does anybody, can you justify your answer? Does anybody want to agree or just, what do you think?
I think I would agree with Karen.
Karen, okay. Why would you agree with Karen?
Because basically so the blue rectangle you draw, basically it's a scaled copy of the first one.
Yes.
So
And what do we know about original distance and copy distance? It gets
multiplied by the same number.
It gets multiplied by the scale factor, right? And we're saying that this 2 is the scale factor. This is twice as big. And we learned that the distance also gets multiplied by the scale factor. So it has to be Karen is right.
okay, I was Karen.
Okay? Because the original distance gets multiplied by the scale factor to give you the copy distance. Think about those figures where we had all the diagonal lines and we ended up having to measure down the middle or across the middle, like a circle. You can't measure the lengths of the circle on graph paper. You had to do the diameter. Okay? Questions you have for me? All right, hang on just 1 minute. Let me turn this off.